Okay, good evening students. In the morning class, we have discussed the exercise 12.1. In that, we have discussed the question number 4 and question number 9. And these two questions are related to unbounded feasible reason. Unbounded feasible reason. Now, I will go for the same exercise. I'll go for the same exercise. Exercise 12.1. Exercise 12.1. Seventh example. Here the seventh example is minimize and maximize z is equal to 5x plus 10y. 5x plus 10y. And subject to constraints are x plus 2y is less than or equal to 120, x plus y equal to greater than or equal to 60, x minus 2y is greater than or equal to 0, and x is greater than 0, y is greater than 0, and these are the constraints. These are the constraints. I will call this is the first constraint, and this is the second constraint, and this is third constraint, and this is our fourth constraint. Okay, now solve this. Okay, what is our problem here? The solution is, our problem is we have to maximize this. We have to maximize or minimize this z value. Alright, our problem is minimize or not or and maximize z equal to 5x plus 10y. We want its maximum value and minimum value. To calculate the maximum value and minimum value, we want its feasible reason. We want its feasible reason. And we know how to calculate the feasible reason. And these are the common reason determined by the constraints. Therefore, you draw these three lines here. Okay, first draw the line x plus 2y equal to 120. To draw this line, we require points. Draw the points. This is x and this is y. And this is x is equal to 0. If this x is equal to 0, we get 2y equal to 120. 2 ones are 2 60s are. Therefore, y value is 60 here. Next. If y equal to 0, then x value is 120. 120. Correct? Okay. Now, after getting these points, what we have to do? We have to draw the graph. We have to draw this line. And for that, we want a Cartesian plane. This is our y-axis. And this is our x-axis. This is our x-axis. This is y and this is x. And this is our origin. And its coordinates are 0, 0. This is O and its coordinates are 0. We want 0, 60 and 120, 0. Therefore, I will write this is scale here. The scale is x-axis. For x-axis, 1 unit equal to 20. And y-axis, 1 unit equal to 20. I'll take this is 20 and this is 40 and this is 60, 80, 100 120, it will continue. Here also 20, 40, this is 60, 80, this is 100, this is 120, and it will continue up to infinity. And what is the first point? The first point is 0, 60. This is a 0, 60. This is our 0, 60. Next one is 120, 0. This is x is 120 and y is 0. This is our 120, 0. And its coordinates are 0, 60 and its coordinates are 120, 0. Join these two. And this is our line. And which line is this? The red line is represented as x plus 2y equal to 120. Now we got the first line. Check whether this line is passing through origin. This line is not passing through origin. Therefore, take this 0, 0, substitute in its corresponding inequality. Put 0, 0 in its corresponding inequality in x plus 2y less than or equal to 120. Here x is 0, y is also 0, and this implies 0 is less than 120. This is true. This is true. True means what? Its solution reason is towards origin. Its solution reason is towards the origin. Means you have to make the solution reason in this side because it is true when if you are substituting 0, 0. I am just making the mark here. What this indicates? Its solution reason is in this side. This mark indicates the solution reason is towards the origin. Okay. Next, what is the next line? Draw second line. Draw the line. Which line? Second line. What is second line here? X plus y equal to 60. And find out the points. The points are x value, this is y value. If x is equal to 0, y value is 60. If y is 0 and this value is 60. Its value is 60. Clear? Now, we got the point now. After getting the point, what we have to do? We have to draw that line. And what is the first one? That is again same 0, 60. Same point. And next one is 60, 0. This is 60, 0. This is 60, 0. And join these two. And which line this is? This is x plus y equal to 60. X plus y equal to 60. Correct? And whether this line is passing through origin, again this blue line is also not passing through origin. Therefore, substitute 0, 0 in its corresponding inequality. Put 0, 0 in its corresponding inequality. Its corresponding inequality is x plus y is greater than or equal to 60. And substitute, this is 0, this is also 0, 60. And this implies 0 is greater than or equal to 60 and this is false. It is false. Okay? 0 is not greater than 60. Therefore, 0 is also not equal to 60. Therefore, its solution region, its solution region is away from the origin. From the origin means its solution region is away from the origin, means in this side, above this blue line. Okay, its solution region we get like here. Its red solution region is towards the origin and blue is away from the origin. Okay. Next, we have one more line here. Again, draw the line. Draw the line. Which line? X minus 2y equal to 0, or it can be taken as x is equal to 2y. X is equal to 2y. And remember, already I told, if any equation is in the form of y equal to mx, and that is the line passing through the origin. Therefore, this is line and it is passing through the origin. Check it. Take 0, 0 first. If x is equal to 0, then y is also 0. Again, don't substitute y equal to 0 here. If you substitute y equal to 0, we get x is equal to 0. Means we get only same point. For that, you can take any other value. I will take x is equal to or y equal to 2. Y equal to 2. If y equal to 2 and x is equal to how much? 4. It is not necessary to take the y. You can take 1. You can take 3. What you want, you can take. You can take negative also, no problem. And what you got the answer is 0, 0 and 4, 2. This is 0, 0. This is 0, 0. And we get 2, 4 here. Yeah. If you are confused where is 2, otherwise you can take. Okay, if you are confused where we have to denote this, you can, because we are taking the unit is 20 now. Therefore, I will take x is equal y equal to 20. If y equal to 20 and x is equal to how much? X is equal to 40. X is equal to 40. Why we are taking like this? You can take any values. If you are taking 2 means we get confused here where we have to we have to look at that point, because we are taking 1 unit equal to 20. Correct? We can take bigger value. Take y equal to 20, we get x is equal to 40. Okay. And where it is? This is x is 40 and this we get here. Okay, this is 40, 0. Join these two lines. Join these 2 points. Join these 2 points. Okay. And what is this point? You get the, yeah. And join these 2 points. Okay. And which line this is? This is x is equal to 2y. X is equal to 2y. Again, this line is passing through origin. No, this line is passing through origin. Therefore, we cannot now don't substitute 0, 0 in its corresponding inequality. If the line is not passing through the origin, on that time you can substitute 0, 0 in its corresponding inequality. But this black line is passing through origin. On that case, we cannot substitute 0, 0. Therefore, put any other point. I'll take any other point. I will take the point is, which one you want? Okay, I will take this. And which point this is? 0, 40. Put 0, 40 in its corresponding inequality. What is that? X minus 2y is greater than or equal to 0. And what is the x value here? 0, minus 2, and this is 40. This is greater than or equal to 0. Correct? And this is minus 80, and minus 80 is greater than 0. This is false, because minus 80 is less than 0. False. False means its solution region is away from this point. Means you have to take the solution opposite to this plane. This is this side. The solution is in this. Correct? Okay. Therefore, its solution region is away from the point, which point? 0, 40. Therefore, its solution is this. And what is the common point itself? Its solution region is in this side. Its solution region is above this one. And its black solution is in this side. Therefore, this is the common reason for these constraints. Okay? And shade this. And this is the common shaded reason. Because here we are getting the feasible reason. Here we are getting the feasible. Because here we are getting the common reason for these three constraints. Why I am taking only in first quadrant? Why I am taking only in first quadrant? Because our fourth constraint. And what is our fourth constraint? The fourth constraint is since right here. Since x greater than 0, y greater than 0, then feasible reason lie in the first quadrant. Okay, and what are the corner points here? The corner points are, these are the corner points. I will denote this is A and this is B and this point is C. We know its coordinates 120, 0 and this is one more corner point. Its coordinates are 60, 0. But we don't know what are the coordinates of A and B. In the graph sheet, we will get how. You just take its color, you just draw the perpendicular to the x-axis and perpendicular to the y-axis, we will get the coordinate of A. But here we will not get. Therefore, I will solve these two equations. This A is what? A is the intersection of black line and blue line. And what is the equation of black line? X is equal to 2y. And what is the equation of blue line? X plus y equal to 60. Solve these two equations and find out the x value and y value, and that are the coordinates of A, right? Okay. For the point A, for the point A, for point A, we have to solve two equations. What is that? First one is x is equal to 2y and another one is x plus y equal to 60. And solve these two. Here x is equal to how much? 2y, and substitute in this equation. This is 2y plus y equal to 60, or this is 3y equal to 60. Therefore 3 ones are 3 20s. Therefore y equal to how much? Y equal to 20. We got y value. After getting the y value, substitute this in equation 1. Therefore x is equal to 2 into y value is 20. This is 40. Therefore the coordinates of A are 40, 20. 40, 20. Therefore the coordinates of this A is 40, 20. Okay. Now we got the A points. Still what we want? We want the points B. Okay? For the point B. And check, B is the meeting point of or intersection of red line and black line. And what is the equation of red line? X plus 2y equal to 120. And what is the equation of black line? X is equal to 2y. And solve these two equations, we will get the B. Okay, for B, we have to solve two equations. X is equal to 2y and another one is x plus 2y equal to 120. and take this x value and substitute in second equation. 2y plus 2y equal to 120, and this is 4y equal to, or y equal to how much? Y equal to 30. We got y value. Next, what is our x value? X is equal to 2 into 30. Therefore, x is equal to 60. Therefore, the coordinates of B are 60, 30. 60, 30. Therefore, the coordinates of this B is 60, 30. Now, we got all the corner points. Now, we got all the corner points. After getting that corner points, what we have to do? We have to substitute those corner points in our Z equation, in our objective function. What is the objective function here? Okay, I have to make one column. Here you have to write the points. Here you have to write the value of Z equal to. What is the Z equation here? Our Z is 5x plus 10y is our Z. And what are the corner points here? A is 40, 20, and B 60, 30, and C is 120, 0, and D is 60, 0, and substitute these values. Okay, and first this is 5 into 40 plus 10 into 20 equal to, this is 5 into 4 is 200 plus this is also 200. We get the 400 here. Correct? Next, 5 and what is the x value here? 60 plus 10 into 30. This is 300. Correct? This is 300 and this is also 300, and sum of these two is 600. Next, 5 into 120 plus 10 into 0, and what do you get the answer here? And here we get multiply if you want. Okay, this is 0, this is 10, and this is 6. Okay, this is 600. This is 600. And if you substitute 5 into 60 plus 10 into 0, we get this is 300. Here we get the 300. And what we want? We want maximum and minimum value. And what is the maximum here? That is 600. We are getting two values, and these are the maximum. And what is this? This is the minimum. This is the minimum, right? Right. Final answer is hence maximum value of Z is 600 at the points. What are the points here? 60, 30, and one more is 120, 0. And minimum value of z is 300. At what point? At the point 60, comma 0. And this is the solution. Okay? Take it. Clear? Okay. Now I will give the 8th one is homework for you. Okay? I will give the 8th question is homework for you. Okay. 8th one is homework. Homework. 8th one. Minimize, same. Minimize and maximize z is equal to x plus 2y subject to constraint x plus 2y is greater than or equal to 100, 2x minus y is less than or equal to 0, 2x plus y is less than or equal to 200, and x is greater than or equal to 0, y is greater than or equal to 0. This is our first constraint, this is our second constraint, and this is our third constraint, and this is our fourth constraint. Okay, this is homework. And we'll get the graph like this. We'll get the graph, nature of graph, we'll get like this. Okay, we'll get the feasible reason here. Here we get the feasible reason. Here we get the feasible reason, and this point is 0, 50, and here this point is 0, 200, and this point is 50, 100, and this corner point is 20, 40. Okay. Next, its maximum value is 400 at the point 0, 200, and its minimum value 100 at the points. Here we get the 2 points. That is, one is 0, 50, and another one is 20, 40. Okay, this is the homework for you. It's just similar to what we have solved in the previous. That is 7th example. You just try this. And this is here we will get the feasible reasons, and these are the corner points. And the maximum value of z is 400 at the point of 0, 200. The minimum value of z is 100 at the points. We get 2 points, 0, 50 and 20, 40. Clear this is? Okay. Now we'll go for 9th one. Already we have discussed 9th one in the morning class. That is unbounded reason. Already we have discussed in the morning class. Now we'll go for 10th. Question number 10. Question number 10. And what's the question number 10 here? The last question in this exercise. Maximize z is equal to x plus y subject to constraint subject to x minus y is less than or equal to minus 1, minus x plus y is less than or equal to 0, and x greater than 0, y greater than 0. Okay, now find out the maximum value of z. Maximum value of z. Okay. This is our first constraint, and this is our second constraint, and this is our third constraint. And third constraint tells us the feasible region in first quadrant. If the feasible region exists, and that feasible region will be in first quadrant. Solution. Our problem is maximize z is equal to x plus y. To calculate the maximum value, we want the feasible region. For the feasible region, you have to draw the lines. Draw the line. What is the first constraint? X minus y. In place of this inequality, you take 1. This is minus. And find out the points. This is x and this is y. If x is equal to 0, we get minus y equal to minus 1. Minus minus cancel, we get 1. If y equal to 0, we get x is minus 1. Now draw these points. This is our x, this is our x dash. Why I am taking x dash now? Because we are getting negative value here. That's why I am taking x dash. This is y and this is y dash. And this is the. Okay, what is the first point here? The first point is 0, 1. Okay, therefore I will take this is 1, 2, 3, 4. This is 1, 2, 3, 4. Okay. Now this side we have minus 1. It will continue. Here we get minus 2. It will continue. Here we get minus 1, minus 2. It will continue. What is the first point here? The first point is 0, 1. This is our 0, 1. And next one is minus 1, 0. This is minus 1, 0. This is minus 1, 0. And join these two. We get the line like this. Okay. Again, this line is not passing through origin. This line is not passing through origin. Okay, right. And therefore, put 0, 0 in its corresponding inequality x minus 1 less than or equal to minus 1. Substitute 0 minus 0 less than or equal to minus 1. That is 0 is less than minus 1. This is true or false? This is false because 0 is greater than minus 1. False. Therefore, its solution region is towards the origin, away from the origin. We get the solution region in this side. Means you have to say in this portion, in this side. Not in this side. Correct? Now, therefore, its solution region is away from the origin. Away from the origin. Correct? Remember, its portion is in this side. You have to. This is the Solution reason. I am taking only in first quadrant. Why? Because of our third constraint. What is our third constraint? That solution, if the feasible reason exists, that will be only in first quadrant. Correct? And what is the second line? Draw the line. Draw the line minus x plus y equal to 0. And here this is y equal to x. Y equal to x. Y equal to x means you can take x is equal to, again this is a line passing through the origin. This is x, this is 0 and this is also 0. If it is 2, this is also 2. If it is minus 1, this is also minus 1, but I will take this, I will not take minus 1. Here this is because we want in first quadrant, this is 3. Right? You can take 2 points or 3 points. Minimum we want 2 points. And this is 0, and remember, if any equation in the form of y equal to x, and that is the line passing through the origin, we get this. This is 0, 0. This next one is 2, 2. Next 3, 3. We get the line like this. Okay, but this line is passing through what? Passing through origin. Passing through origin. Therefore, don't take 0, 0 and substitute in equation. But you take any point in this side or in this side. I will take this point. What is this point? This is 2, 0. Put 2, 0 in. This is clear. Why I am not taking 0, 0? Because this line is passing through origin. If it is passing through the origin, you cannot take 0, 0 to substitute in its corresponding inequality. In minus x plus y greater than or equal to 0. And this is minus 2 and this is 0 and minus 2 is less than what? 0. Therefore it is true. Therefore its solution reason is in this side, towards this point, because it is true now. If it is true means its solution reason is towards this point, and this point is here. Therefore, its solution reason is in this point. This is the solution reason of this line. Okay, only in first point. Correct? Is there any? This is the solution reason of this line, and these two lines are parallel. Okay. Okay. Check whether we will get the feasible reason here, whether we will get the common reason here, whether we are getting common reason. No. Therefore, here we don't have any feasible reason. If you don't have any feasible reason means we don't have any maximum value. Clear this is? Right. Here no feasible reason. Here no feasible reason. Therefore there is no maximum. Therefore there is no maximum value of set. There is no feasible reason, no maximum value of set. That is, here no feasible reason, comma, therefore no maximum value of set. Because here we are not getting feasible reason means here we cannot calculate the maximum. Therefore, here no feasible reason, therefore no maximum value of set. Clear why we are not getting maximum value? Because here we don't have any common reason. We don't have any feasible reason. Therefore, Z has no maximum value. And this is your exercise 2.1. And the next exercise is, actually this is a deleted syllabus. That is, they will give the problems in word units and word problems. but they will not ask in the examinations. They will not ask in examination, but for your knowledge, we are solving 5 to 6 questions on the word problems, and that is our exercise 12.2. Okay, they will not ask the word problem because they are deleted that one. Correct? Now, for your knowledge, I am solving 5 to 6 word problems. Means there will be the word problem. You have to convert that word problem into mathematical form the same way, and you have to solve that one. Okay? And that is our exercise 12.2. Okay? Now, example. That is solved example. The first example is take up. It is very lengthy question. Taken. Solved example. Solved example. Okay. And usually they will not ask word problem. Actually, they are deleted syllabus. They are putting deleted syllabus. For your knowledge, we are going to teach that 5 to 6 questions on the word problems. Okay. The first one is a corporate cooperative cooperative society of farmers has 50 hectare of land to grow two crops A and B. The profit from the crops A and B per hectare are estimated has Rs 10,500 and Rs 9,000 respectively. To control which a liquid herbicides has to be used for crops A and B at the rates of 20 liter and 10 liter per hectare. Further, no more than 800 liters of herbicides should use should be used in order to protect fish and wildlife using a fund which collects drainage from this land. How much land should be allocated to each crop so as to maximize the total profit of the society. And this is the question. Okay, this is a very lengthy question. Okay. Now, the given problem, the given wordings in the wording problems. Now, convert this word problem into a mathematical formulation. And this is very easy to convert into mathematical formulation. Okay. And first, observe what is this problem. We have one cooperative society of farmers. We have one society. That society has 50 hectare of land. That society has 50 hectare of land. Yes, totally how many hectares it is? 50 hectares. Now, to grow two crops, here they will, in this land, they will grow two crops, A and B. They will grow two crops, A and B. And the profit of crops A and B per hectare are estimated as the profit of A crop is 10,500. And the profit of B crop is 9,000. Okay, next, to control the weeds, the liquid herbicides has to be used for the crop A and B. We have to use the herbicides for this A and B to control the weeds. And in which rate we have to use? At the rates, we have to use 20 liters herbicide per hectare for the A and 10 liters for the B per hectare. Next, per hectare. Further, no more than 800 liters. Then some of the herbicides not exceed the 800 liters. Why? Of herbicides should be used in order to protect the fish and wildlife using the fund which is collected drainage from this land. Now, what we want and how much land should be allocated to each crop so has to be maximize the total profit of the society. Okay, this is clear. The society has 50 hectare of land. In that land, they will grow two crops, A and B. Correct? And the profit of this A crop is 10,500 rupees, and profit of this crop is 9,000 per hectare. Next, again they use herbicides for the both, and 20 liter per hectare for this crop A and 10 liter per hectare for this crop B. Now the society wants the maximum property. For that, how many land out of 50 hectares, how many land we should allocate for the crop A, and how much land we have to allocate the land for the crop B. In that case, we want the maximum profit. We want maximum profit. Then here what we have to do? We have to make the column here. We have to make the table for this. Okay. What are the two main things here? Crop A and the crop B are the main things here. That are the variables. Okay. Here what they are asking? First, I will convert this into mathematical formulation. What they are asking? How much land should be allocated to each crop so as to maximize the profit. Okay, I will take, let x be the okay, how much land should be x hectare, they given in the hectare now, hectares, x hectare, let x be the x hectare allocated for crop B. We don't know how much they are allocated for the crop A. I will take that is A. Correct? And let y hectare allocated for the crop B. We don't know how much land we are allocated for the crop A and crop B. I'll take x hectare for the crop A and y hectares for the crop B. Okay. Now calculate the maximum profit. Calculate the maximum profit. Okay. I will remove it. Okay. What are the two main things here? Crop A and this is for crop B. You have to take two crops. Here are the availability. Availability, okay. You have to make these columns. Okay. And the first restriction is, for that society only has 50 hectare land. That is a restriction. That society not more than 50 hectares, not less than. It has maximum, it has only 50 hectare land. Therefore, the first constraint is for the land. Okay. How many land is allocated for the crop A? We have taken this is X. And for the crop B is Y. And what is the highest land it has? At most, we have to use at most 50 hectares. We have to use only 50 hectares. Therefore, at most 50 hectares. Sum of these two, addition should be at most means less than or equal to 50. And what is the next restriction? The next restriction is herbicides. herbicides. Right? They given next is herbicides. Okay. And how much herbicides we have to use for this A? Per hectare we have to use 20 liters. But how many hectares we are taking here? X hectares. Therefore, totally how many herbicides you are using for the crop A? That is 20x. Per hectare we have to use 20 liters. But how many hectares we have? X hectares. Therefore, total herbicides we are using for this crop A is 20x. And for the crop B, how many herbicides we are using? That is 10 liter per hectare. But how many hectares we are using for the crop B? Y. Therefore, this is 10y. And also they given not that usage of this herbicides not more than the 800 liters. Means sum of this is what total number of herbicides used in the crop A, and this is the total number of liters used for the crop B, and sum of these two not exceed. Exceed means not more than means at most, highest, at most we have to use only 8 liters. Sorry, 800 liters. Correct. Next, also they given profit for the both. Profit. And what is the profit of A? Per hectare they given 10,500. But how many hectares we are using? X hectares. Therefore, this is 10,500x. And what is the profit of crop A per hectare? 9,000. 9,000 into Y. Here they not 9,000 into Y. Here they not given any restrictions on the profit. They want maximum profit. They want maximum profit. And remember that x greater than 0, y should be greater than 0. Why? If you are not using any land for the crop A means the x is equal to 0. If you are not using any crop for the B means y equal to 0. If you are using any land for the crop A means that should be greater than 0. If you are using any land for the crop Y, that should be greater than. It cannot be negative. These are the non-negative constraints. It should be there. Okay. Now we got the similar thing what we solved in the exercise 12.1. Here what we have to maximize? Here what we have to maximize? We have to maximize the profit. Therefore, take Z is equal to. And we have to maximize this one now. Therefore, take Z is equal to 10,500x plus 9,000 because we have to maximize the profit. We have to maximize the profit. Therefore, take Z is equal to 10,500x plus 9,000. Next, what are the constraints? The constraints are sum of these two, x plus y, the number of hectares used for the crop A and number of hectares used for the crop B. Sum of these two, it should be what? At most means you just use less than or equal to 50. We don't have any land more than 50. You can use less than 50. Okay, we cannot use more than 50 because society has only 50 hectare land. Next, that is 20x plus 10y. This is the constraints on the herbicides. At most means again this is 800. If they ask at least, in place of this they are used at least. On that time you have to take the greater than or equal to. Okay? And we have two more examples, that is x is greater than 0 and y is greater than 0. These are always present. These are non-negative constraints. Again, we get the same thing what we solved in the exercise 12.1. This is our z and these are the constraints. And we know how to solve this. Okay, now we will solve this one. Clear this is? Okay. Now I will write it down. Here we want maximum profit. We want maximum of this. We want Right. What you want, you can write in bracket. We want maximum of this state. Okay. To get to, if you want the maximum value, what we have to do? First, we have to draw the line. Okay. Draw the line. Which line? What is the first one? That is x plus y equal to 50. And what are the points here? X is 0 and y is 50. If y is 0 and this is 50. Correct? Okay. Now draw this line. This is clear how we are converting that word problem into mathematical formulation. Next. This or y. This is actually they will not ask in exam, but you are in for your knowledge we are telling that word problems. Okay. Next, the first point is this is 10, 20, 30, 40, 50, 60. You can write the scale of it. And this is 10, 20, 30, 40, 50, 60. Okay. Now what is the first point? 0, 50. This is 0, 50. Next one is 50 points. And join these two. And we know how to solve this. We have solved so many examples on this. Okay. And this equation is x plus y equal to. Okay. Okay. And this line is not passing through origin. Put 0, 0 in its corresponding inequality. X plus y is less than or equal to 50. This is 0, 0 less than or equal to 50. 0 is less than or equal to 50. This is true. Right? This is true. True means what? Its solution reason is towards origin. Towards origin. Means we get the solution reason in this side. We have to make the stated. Okay. Next, what is the next line? Draw the line that is 20x plus 10y equal to 800. And find out the points. This is x and this is y. If x is equal to 0, we get 10y equal to 800. That is 0, 0 cancel, we get 80. We get 80. Next, if it is 0 and 200, we get the 40. 200 to 40. Okay. And what are the points here? This is, we get here 0, 80. Okay. And here we get the 0, 40. Join these two. And what is this equation? Its equation is 20x plus 10y is equal to 800. Okay. And what is the next constant tells us? The feasible reason is on the first. Right. Put 0, 0 in its corresponding inequality because that black line is not passing through origin. In 20x plus 10y less than or equal to 800. This is 0. This is also 0. 0 is less than or equal to 800. This is true. True means its solution reason is also towards the origin. Its solution reason is also towards the origin. Correct? Therefore, its solution reason is towards the origin. Okay. And what is the third constant? Since x greater than 0, y greater than 0, then feasible reason is in the first quadrant. In the first quadrant. Okay. Therefore, its feasible reason is, this is the common reason. Okay. And these are the corner points. These are the corner points. And what are the corner points here? This is the feasible reason, right? This is the feasible reason. And the corner points are here. This is 0, 50, one corner point. This is 0, 0 is another corner point, and this is 40, 0 is another corner point. But we don't know. This is take O, and this is A, and this is B, and this is C. But we don't know what are the coordinates of B. And we know how to solve that one. Okay, right. For the point B, we have this point is intersection of what? Black line and blue line. Solve those two equations. What is that? X plus y equal to 50, and this is 20x plus 10y equal to 800. Okay. Listen, now I will make the coefficient of y same. I will multiply 10 for this. And what do you get the answer? 10x plus 10y equal to 500. And this is 20x plus 10y equal to 800. Multiply 20 here. Sorry, 10 here. Because I am making coefficient of y same. This is minus minus minus. Cancel. This is minus 10x and this is minus 300. It cancel. Therefore, x is 30. X is 30. If x is equal to 30, then what is the y value? We have that x plus y equal to 50 now. This is 30 plus y equal to 50. Therefore, y equal to how much? 20. Therefore, the coordinates of this B is, what is the x value? 30 and y value is 20. Now we got all the corner points. Now calculate your z value for the corresponding corner points. For that we have to make one column. This is for this is corner point. This is corner points, and this is z is equal to, what is that equation? Z is equal to 10,500x plus 9,000y. Oh, this is very linear. Okay. Now, what is the first one? 0, 0, and second A is 0, 50, and B is 30, 40, and C value is 40, 0. Substitute. If you substitute x is equal to 0, we get x0, y0, this is 0. And 0, 50. If 0, 50 means 9 5s are 45. This is 4,50,000. Calculate. But to multiply 19,000 into 50, we get 4 lakh 50,000. 4 lakh 50,000. Now substitute x is equal to 30 and y equal to 20 and multiply, we get around 4 lakh 95,000. 4 lakh 95,000. Okay. Next, if you substitute x is equal to 40 and y equal to 0, we get around 4 lakh 20,000. 4 lakh 20,000. Okay. Among this, which one is maximum? This is the maximum. Therefore, maximum or maximum profit, we will get the maximum profit when if you allocate 30 hectare for the crop A and the 20 hectare for the crop B. Okay, right? We will get the maximum profit. The maximum profit is 4 lakh 95,000 when okay, we get the 4 lakh 45,000 at 30,000 30 20 at the point 20 30, that is 30 hectare and 20 hectare allocated. They given allocated. Okay, allocated for. Otherwise, we can just write here what we have to write. Hence society. Otherwise, we can write. Hence society. Hence society. Hence the society will get maximum profit when maximum profit of 4 lakh 95,000 by allocating 30 hectare 30 hectares for crop A and 20 hectares for crop B. This is the problem. This is clear. How to convert that word problem into mathematical formulation. After calculating this, nothing is there. What we did in the exercise 12.1, the same thing we did here. Okay. After that, we calculate principal reason. We got the corner point. At this point, we are getting the maximum value. The maximum value is 4,95,000. At what point? 30, 20. What this is? X value. What is the X value? That is the X is the X hectare of. We are using X hectare for the crop A and Y for the Y is Y hectare we are using for crop B. Therefore, we are right. Hence, the society will get the maximum profit 4 lakh 95,000 by allocating 30 hectares for the crop A and 20 hectares from the crop B. This is clear? Okay. The same thing what we did here. Okay. And one more. Now again I will explain how to formulate this. Okay. And that is the very important. Once if you know how to formulate mathematically in mathematical form, we can solve very easily because already we have solved around 10 to 12 questions on that one. Okay. Now I will convert same thing, the same example. I will convert it to here in this example, the same example. crop A and crop B are the two main ingredients. Okay, two things. You have to make two columns for that. That is for the given crop, for the crop A. This is crop B. You have to make two columns. What are the two important things now? And that you have to take the into columns. Okay. After that, here you write the availability. The last column you have to write the availability. And here you will take one more, because here we have to write the what are the constraints. What are the constraints? Here this is the same example I am using. I am again just formulating this because this is the important. Okay. And what is our first restriction? The first restriction is land, because that society has only 50 hectare land. That is the first constraint. We cannot go above 50 hectares. That is the highest. Therefore, I will take what is the x? Let x be x hectare be the land allocated for A. Think this is A. And y is the land allocated for the crop B. For the crop B. Okay. And sum of these two should be what? Should be less than 50. Should be less than 50. Because sum of these two hectares should be what? At most it should be 50. You can use less than 50, but the highest is 50. This is land constraint. After that, one more constraint we have, that is herbicides. We have to use only not more than 800, not 800 liters. That is the restriction for us. That is the constraint. This is herbicides. And for 1 hectare of crop A, they are using 20 liters. But we are using how many hectares here? X hectares. Totally this is 20x. And this is, they are using how many liter for the crop B? 10 liter. This is 10. Correct. After that, what they given? They given profit of these two. Right here, profit. And what is the profit of crop A per hectare? 10,500. Because we are using X. Here we are 9,000. Okay, they are not restricted. This is not restricted. Here, what we have to maximize? We have to maximize the property. Therefore, take that is Z is equal to, that is 10,500x plus 9,000 y. And this is, we have to maximize. This is our objective function. After that, what are the constraints? What are the constraints? That is x plus y should be less than or equal to 50. And one more, 20x plus 10y should be less than or equal to 800. And these are the constraints. And we have that non-negative constraint you have to take. Because x here, it cannot be negative. This is also cannot be negative. Therefore, this is a constraint. After getting this, we know how to solve the LPP using corner point method. You calculate the feasible region and calculate the corner point and substitute in Z value. Which one is the maximum value? That is the maximum value of Z. Which one is the minimum? That is the minimum value. Okay, this is clear how to make the formulation. Otherwise, you got to know up to 50%. Now I'll solve 4 to 5 examples. You will come to know how to convert that word problem into mathematical form. Clear this is? Okay, take it. In the next class, I will solve around 4 examples, and after that they will start another chapter. Okay, and don't bother about this word problem. They will not ask that word problem. Okay, because in that deleted syllabus they have deleted that word problem. For your knowledge, I am solving that. Okay, that unbounded, don't bother about unbounded also. Okay, only you consider that bounded and that constraints. Okay, if they ask, already we know how to solve that one. You can solve. No problem. Clear this is? You try this also.